All sources, citations, and information belongs to their respective researchers, universities, magazines, articles, and platforms, and I am sharing this information with compliance to fair use. I want to share different articles with you regarding melanin, its uses in science. And the articles I'm sharing speak about electricity, batteries, pricing, different things that I would not, prior to this research, know that melanin had any connection to. Before I get into what melanin can be used for, I want to explain what it does and what it is. To do so, I will share excerpts from phys.org. And it's entitled, Study Reveals New Insights on the Mechanism of Melanin Formation. It was written on January 10th, 2023 by Dashisha University.
The skin is presumably the largest and one of the most versatile body organs. By providing a physical barrier, it protects our body from environmental assaults. Melanin, a natural pigment produced by specialized skin cells called melanocytes, shields our body from the detrimental effects of ultraviolet radiation.
I want to first start out with phys.org. This platform shares information on nanotechnology, physics, earth science, astronomy and space, chemistry, biology, and other sciences, including medicine and other forms of technology. It's a news platform. Excerpts from an article entitled Researchers Discover Melanin Could Make for Great Batteries by Emily Durham, Carnegie Mellon University, Mechanical Engineering, and the article from phys.org.
Melanin is best known as the pigment that dictates our skin tones, but it is found just about everywhere, in our brains, in our hair. It is even found in cuttlefish. But as abundant as melanin is, its exact macromolecular chemical structure is surprisingly not well understood. Though researchers have extensively studied the chemical structure of individual melanin molecules for more than 70 years, relatively little is known about the molecular building blocks that form complex melanin pigments. But a team of researchers from Carnegie Mellon University has discovered that the chemical structure of melanin on a macromolecular scale exhibits, amongst other shapes, a four-membered ring, in other words, a chemical structure that may be conducive to creating certain kinds of batteries based on natural melanin pigments. The research team was able to discover the tetramer structure of melanin by using it as a battery's cathode. However, in doing so, they also discovered that melanin exhibits a 2-voltage plateau characteristic of normal battery materials, while outputting a surprisingly high voltage. Excerpts taken from article titled, Researchers Discover Melanin Could Make for Great Batteries, by Emily Durham, Carnegie Mellon University Mechanical Engineering. Written on May 17, 2016. Also, you can find the full article titled Evidence of Porphyrin-like Structures in Natural Melanin Pigments Using Electrochemical Fingerprinting in Advanced Materials.
MedDevice Online shares information regarding medical technology and news updates, design and development, regulatory, manufacturing, and supply chain, industry news, and expert insights. This article, written August 25, 2016, entitled, Batteries Made from Melanin Could Power Indigestible Devices, by Suzanne Hodson.
The success and safety of ingestible electronics depends on the biocompatibility of their components, and the most potentially toxic part of an electronic device is the battery. Now, scientists from Carnegie Mellon University have developed a battery made from melanin, a naturally occurring compound in human skin, eyes and hair, which they say can power a 5 milliwatt device for 18 hours. Researcher Christopher Bettinger published an article in Trends in Biotechnology last year discussing progress worldwide in the development of smart pills, which he claims will make medications much more efficient and safe if they are made from the most biocompatible materials. Bettinger's vision was to go to the FDA with a list of ingredients already present in human bodies and permitted in human food and present an ingestible device built from those materials. After experimenting with materials like manganese oxide, copper, and melanin, his team developed a battery capable of powering a small sensing device or drug delivery system. "We found basically that they work," said Hang-Ah Park, postdoctoral researcher at CMU. "The exact numbers depend on the configuration, but as an example, we can power a 5 milliwatt device for up to 18 hours using 600 milligrams of active melanin material as cathode." Bettinger argues that 600 milligrams isn't nearly enough melanin to be harmful to a human system. "If you've ever had squid ink pasta, then you've already swallowed lots of melanin," Bettinger told Bloomberg. Excerpts taken from the article. To read the full article titled, "Batteries Made from Melanin Could Power Ingestible Devices," by Suzanne Hodgson, written on August 25, 2016 from Med Device Online. Snippets from American Chemical Society. Melanin and ingestible batteries.
Katie, thank you so much for having me. So it's my pleasure to discuss our discovery and innovation in the world of polymers as they apply to batteries for ingestible medical devices. And so really what we're talking about here today is the notion that you can use biologically derived materials as important components of an ingestible battery. And so our broader vision for this work is really thinking about batteries as they exist today and making them application specific for edible electronics. And so specifically what we've discovered is that we can use melanin pigments. These are the same pigments in your hair, in your skin, and your eyes as components for these ingestible batteries. And so these have significant advantages over existing batteries because they're designed for this purpose. So we've basically one by one replaced the potentially toxic components of a battery with that of benign endogenous materials within the human body. And so at this specific meeting, what we're reporting is essentially a very specific dependence of the performance of these batteries as a function of the ion within the body. So we've previously shown that we can use things like sodium to replace lithium and other kinds of ions, but here we're exploring other kinds of ions like aluminum and iron. And what we've really discovered is this is a way we can not only think about new kinds of cations, but also then learn something about the biology of melanin as a pigment.
To watch the video in its entirety, it's titled, "Battery You Can Swallow Could Enable Future Ingestible Medical Devices." It's from American Chemical Society. Now we're going to speak about melanin and electricity. Frontiers, as stated, is the third most cited and the sixth largest research publisher and open science platform. It provides research journals and peer-reviewed content from over 200,000 researchers. The platform speaks about technology, including artificial intelligence. Frontiers Science News. Will cyborg circuits be made from melanin? Posted on March 26, 2019 by Frontier Science Communications in Engineering, Featured News, Robotics, and AI.
In a landmark study published in Frontiers in Chemistry, Italian researchers subtly modified the structure of eumelanin by heating it in a vacuum. Our process produced a billion-fold increase in the electrical conductivity of eumelanin, This makes possible the long-anticipated design of melanin-based electronics, which can be used for implanted devices due to the pigment's biocompatibility. All of the chemical and physical analyses of eumelanin paint the same picture of electron-sharing molecular sheets, stacked messily together. The answer seemed obvious: neaten the stacks and align the sheets, so they can all share electrons, then the electricity will flow. The conductivity of the films increased with increasing temperature, from 1000-fold at 200 degrees Celsius. This opens the possibility of tailoring eumelanin for a wide range of applications in organic electronics and bioelectronics. It also strongly supports the conclusion from structural analysis that annealing reorganized the films, rather than burning them. There's one potential dampener: immersion of the films in water results in a marked decrease in conductivity. This contrasts with untreated eumelanin, which, albeit in a much lower range, becomes more conductive with hydration because it conducts electricity via ions as well as electrons. Further research is needed to fully understand the ionic versus electronic contributions in eumelanin conductivity, which could be key to how eumelanin is used practically in implantable electronics. Excerpts taken from article titled, "Will Cyborg Circuits Be Made from Melanin?" Posted on March 26, 2019 by Frontiers Science Communications and Engineering, featured news, robotics and AI. Frontier Science News. Snippet from Electronic Wonders of Melanin.
Over the past decades, researchers have focused on what might be melanin's most promising talent yet discovered: the ability to conduct electricity. That's important, because if we fancy a future where environmentally benign electronics help us fight disease, monitor our health, and store energy, we're going to need bio-friendly materials. And what better material for the job than one made right in-house? Because melanin is 100% compatible with our body's makeup, it's a much safer starting material for building electronic devices, both for us and the environment. Researchers are still learning how melanin behaves when surrounded by the machinery that makes useful electronics work. But continued efforts from chemists, physicists, and materials scientists are likely to result in exciting new applications for this highly versatile molecule.
To watch the video in entirety, it's entitled The Electronic Wonders of Melanin by Research Square. Melanin in Space. Johns Hopkins Bloomberg School, Public Health, has a magazine, and this article from the magazine entitled Melanin in Space. Melanin samples are headed to the International Space Station to test their ability to protect against radiation, by Rin Yuan, and illustrations by Zhong Huang.
The pigment plays multiple roles in biology. A lot of organisms use melanin to capture heat from the environment. It is very good at absorbing electromagnetic radiation. With a seed grant from the Bloomberg School Technology Development Accelerator Fund, Cordero and his collaborators have isolated melanin from fungi and begun exploring its properties and potential applications. Soon, they will be able to test how well melanin will hold up in space. NASA will send Cordero's samples, in the form of fungal melanin composite discs, to the International Space Station in late October. Excerpt taken from article titled Melanin in Space. Melanin samples are headed to the International Space Station to test their ability to protect against radiation. By Rin Yu. And illustrations by Dong Hong. Video snippets from Ignite Baltimore, featuring Dr. Radames J.B. Cordero.
Good evening. Thank you, Ignite Baltimore, for the opportunity. My name is Radames, and today I would like to talk to you about melanin and why we are sending it to space. So after all these years, we are finally going back. We are going back to the moon by 2024, this time including the first female, After that, Mars. So without a doubt, we are living in a very exciting time. Luckily, biology has been dealing with the problem of radiation and temperature for a long time, eons of evolution. And one way biology solve or deal with this problem of radiation and temperature is via a special class of biomolecules called melanins. Melanins are pigments, not hormones. That's melatonin. Melanin is a pigment that is found everywhere. Look around you. We're covered by this stuff. Animals, plants, fungi, bacteria, they all express melanin. I like to classify them in three big groups. First, visual communication. So if you're an organism that can see, or vision is relevant to you, you may use melanin to decrease or increase visual communication. The other big role of melanins in biology is protection, and we are very familiar with that, right? So melanin protects against ultraviolet radiation. It absorbs that frequency and dissipates it into heat, therefore protecting the underlying tissue. I'm a scientist. 4 years ago, I started working on this. I use black fungi as a model system to study how melanin interacts with radiation and dissipates heat. And I am interested in black fungi because some of these species are able to survive in one of the most extreme environments here on Earth, like Antarctica, for instance. Some of these environments have high radiation. We learn a lot from what happened in the Chernobyl disaster several years ago, where we noticed that observations were made where melanotic microorganisms were not only surviving in these environments, they were thriving in these high levels of radiation. So this stimulated a lot of research, summarized in this article, that suggested that melanin, fungal melanins perhaps are able to protect.
To watch the video in its full entirety, just type in Radamés Cordero, melanin-based applications for human space exploration. It's Ignite Baltimore. This is featured on the Ignite Baltimore platform. It has many different chapters in it. Very informative discussion on testing melanin, seeing how it would fare against radioactive activity within space. And those were just small snippets regarding the subject.
Patenting melanin.
This article, entitled River Road Research awarded a patent for melanin production. Process will enhance production of melanin for a wide range of business applications, as well as reduce environmental impacts of food waste. The news is provided by River Road Research on January 27, 2015 at 11:10 Eastern Time.
Many scientific studies have verified that melanin has unique characteristics for a wide range of applications, especially in the pharmaceutical, cosmetic and battery technology sectors which have growing global demand, said Kenneth Nielsen, Ph.D., Vice President of Research at River Road Research. Research Director Radu Popa, Ph.D., added, "Our patent is unique in that ordinary food waste is the only feedstock required, and that it is a biological process that technically requires no inputs such as energy or water." In its patent, River Road Research received intellectual property protection for the various methods it uses to produce melanin. The first step of the process involves a proprietary fermentation of the food waste that produces a nutrient-rich leachate. This leachate is then secondarily processed utilizing a fly larvae as a bioreactor. The flies are indigenous to many parts of the world, including North America, and are harmless to humans. River Road Research has several other projects involving the insect which is commonly known as the black soldier fly or Hermetia lucens. What we are doing is manufacturing melanin and then concentrating this rare and expensive commodity for the benefit of the marketplace, said River Road Research Managing Director Scott Ernst. We are very excited about the significant opportunities for the company in the global marketplace, particularly in supporting the development of more environmentally friendly battery technologies. River Road plans to make the technology available through licensing, but can also provide bulk material to those looking to develop applications. Excerpts taken from article titled, River Road Research awarded a patent for melanin production. News provided by River Road Research. January 27, 2015, 11:10 Eastern Time. Scion PR Newswire. Melanin pricing.
Millipore Sigma, according to its website, it is a leading supplier to the global life science industry with solutions and services for research, biotechnology development and production, and pharmaceutical drug therapy development and production. According to its About page, researchers around the world rely on our tools, services, and expertise to do their best science. From familiar experiments to novel approaches, our presence extends well beyond the labs as our innovations touch individuals around the world. Together, we impact life and health with science. So this platform caters to different applications, products, services, and it sells life science materials. We're going to look at the pricing of one of the life science materials on this platform, which would be synthetic melanin. In order to find the pricing of synthetic melanin from Millipore Sigma, just go to the search bar and type in melanin. From there are 31 results labeled within products. There are 2 items, at least from my search, that have this title melanin in them. One referred to as synthetic bioreagent suitable for cell culture, and the other simply referred to as synthetic. By clicking the names, I'll start with the bioreagent. This item at 100 milligrams is $110. And at 1 gram is $549. The synthetic at 100 milligrams is at $107. At 250 milligrams is at $182, and at 1 gram is $547. ChemDirect also sells melanin in synthetic form. Depending on your quantity, the price adjusts. But the price per unit, at least per this page, is $1,361.06. This in size 1 by 1 gram. That is all I have for this video about melanin in pricing, space technology, electricity, ingestible batteries,
and patenting.
There are many properties to melanin that I may not have considered prior, and maybe even more than I've shared. Thank you so much for listening, and stay tuned for more.